Hello everyone, section 10.5, angle relationships in circles. Example 1, line M is tangent to the circle. Find the measure of the red angle or arc. So in this case we're trying to find the measure of this angle 1. This angle 1 intercepts this arc AB. It's a major arc, so I can't really name it arc AB, but the measure of that arc is 240 degrees. Measure of angle 1 is half of that. So measure of angle 1 equals 120 degrees. We're told here in part B that the measure of this angle is 155 degrees. We're looking for the red arc, LJK. LJK is being intercepted by this angle, MLK, and it's got to be double that measure. So the measure of arc LJK has to be equal to 310 degrees. Now the next major concept in this unit is outside, inside, on. Depending on where the two secant lines, non-parallel lines, are intersecting the circle, I suppose they can be tangents. We're going to get to that later. But if they're intersecting the circle, where they intersect each other, whether that is happening outside the circle, inside the circle, or on the circle, determines whether we add or subtract and then divide by 2 the intercepted arcs. So if they intercept inside the circle, then we add these two intercepted arcs together, divide by 2. If they are outside the circle intersecting, then we subtract the two intercepted arcs and divide by 2. And if it's on the circle, then it's just an inscribed angle, and we're just going to divide by 2. There's nothing else to add or subtract to it. All right, so example 2, find the value of x. So if this is 94 degrees, then this angle here is going to be 180 minus 94. 180 minus 94 is 86 degrees. And this angle, because it's intersecting inside of the circle, is equal to x plus 80 divided by 2. So 86 degrees equals x plus 80 divided by 2. Multiply both sides by 2. 86 times 2, 172. Equals x plus 80, subtract 80, x is equal to 92 degrees. In part B, our intersection angle is occurring outside of the circle, so we subtract the 2, and then divide by 2, and that's gonna equal this angle. So 100 minus x over 2 equals 35 degrees. Multiply both sides by 2. 100 minus x equals 70. Add x, subtract 70. X equals 30 degrees. Now, this next concept wasn't in our previous geometry textbooks. And it actually makes things a lot easier. This circumscribed angles theorem, I wish I had had it in the past, but I didn't. I do now, and it's pretty neat. It tells us that this central angle, the exterior angle is equal to 180 degrees minus the central angle that intercepts the exact same arc, QP in this case. So and this is formed by two tangents, so this angle's got to be formed by two tangents, circumscribed angle theorem, and the intercepted arc, and then you get your central angle. So x is equal to 180 minus 124. So 180 minus 124, x is equal to 56 degrees. Part B. So we're going to find the measure of this inscribed angle. This inscribed angle is equal to half of this intercepted arc here, because it's an inscribed angle. This intercepted arc is equal to the central angle. So if we can find the measure of the central angle, knowing the exterior angle, and then divide it by 2, we're going to get this arc. So I'm going to find angle AOB first. So measure of angle 180 minus the measure of arc AB or angle AOB. I'm going to go with arc AB, just a little less writing, is equal to 42 degrees. So subtract 42, add measure of angle of arc AOB, measure of arc AB is equal to 180 minus 42, 180 minus 42, it's 138 degrees. And the measure of angle ACB, or x, is half of that by the inscribed angles theorem. So x is equal to half of 138, or 69 degrees. Well, 4. The northern lights are bright flashes of colored light between 50 and 200 miles above the Earth. A flash occurs 100 miles above the Earth at point C. Find the measure of arc BD, the portion of the Earth from which the flash is visible. So there's actually a circle that goes around the Earth. There's a line of latitude that you would, below that line of latitude, you wouldn't be able to see the northern lights. Above the line of latitude, you would be able to see the northern lights. And that's what we want to be able to figure out. What's this angle ABD in the arc measure BD to figure that out. So let's first find out the measure of angle BAD, which is the same as the measure of arc BD. Okay, and we're going to have to do that by doing, so we know because the radius of the Earth is about 4,000 miles and point C is 100 miles above it, AC is 4,100 miles. Okay, the radius is 4,000 miles. What else do we know about tangents and radii? And you can't really see it. It's hard to see, but it's actually drawn in the picture. Tangents and radius to the point of tangency form right angles. So we have a right triangle here. Triangle CDA and triangle CBA are right triangles. 4,000, 4,100, and the right angle. And we want to find this angle here, which is this angle here, angle A, and then double it, find them, and then that will tell us the measure of arc BD. Okay, so SOHCAHTOA is going to tell us the measure of that angle. This is adjacent, so cosine angle A equals 4,000 over 4100, or 40 over 41. Inverse cosine is going to tell us the measure of angle A. I'll turn my calculator here. 40 divided by 41. And then inverse cosine, make sure we're in degrees, and we get approximately 12.7 degrees. And we want to double that to find the measure of angle BAD, or arc. The measure of arc BD is twice this, so times 2, 25.4 degrees. And that's what the question's asking us for. 25.4 degrees, the measure of, so the line of latitude, well, 25.4 degrees from here is what we'll be able to see the northern lights. That's example 4. Example 5. We want to find the measure of x. The measure of x is going to be 180 minus 92. Or 88 degrees. And we want to find part B, the measure of angle x again, or arc x. This intersection is occurring inside the circle, so we add these two together, divide by 2, and that equals 94. X plus 112 divided by 2 equals 94. Multiply by 2. X plus 112 equals 188. And subtract 112. X is 76 degrees. Example 6. An advertising agency wants a frontal photo of the flying saucer ride at an amusement park. So I found the flying saucer ride at the amusement park. The photographer stands at the vertex of an angle formed by the tangents to the flying saucer, and they have a 72-degree angle for their lens of their camera. So what's the measure of the arc XY in this particular problem that they would be able to see? So how many degrees is it from here to here? How many degrees is it from here to here? If they have a 72-degree angle on their lens. So the measure of arc XY subtracted from 180 is equal to 72 degrees. Subtract 72, add the measure of arc XY. The measure of arc XY is equal to 108 degrees. Example 7. Navigation. The map shows that the waters within arc AXB, so the waters inside of this arc, are unsafe for a boat. Shallow reefs. It's just unsafe for boating. Okay, and it's from AXB is a 300-degree arc. Here are the letters, what letters represent. A is a lighthouse, B is a lighthouse, X is a ship on the circle O, Y is a ship inside of circle O, and Z is a ship outside of the circle. Okay. What is the measure of angle X? Well, if arc AXB is 300 degrees, then arc AB is 60 degrees. And the measure of angle X is half of that because it's an inscribed angle, so it's 30 degrees. So if it's 30 degrees, what could the angle y be and what could the angle z be? Well, let's first think, does y get bigger or smaller than x? Does z get bigger or smaller than x? One does one, the other does the other. So here's x at 30 degrees. Y is getting closer to AB. It's inside of the circle. And as we move forward, that angle y is going to be opening up. As we move forward closer and closer to arc AB, it's going to open up. As you move back, angle Z is going to close. It's going to get smaller. So, what's the range of measures for angle Y? Angle Y has to be bigger than 30 degrees, but it can't get bigger than 180 degrees. So, 30 degrees is less than Y, less than or equal to 180 degrees. What about Z? Z is going to get smaller and smaller and smaller. It's going to get smaller than the 30 degrees. Well, it can't get to 0, so it's going to be 0 is less than Z, 0 degrees, is less than Z, which is less than 30 degrees. So Y is between 30 and 180, Z is between 0 and 30. Using the angles in the ships a ship makes in the lighthouse, like X, Y, and Z, explain how a navigator can help make sure that the ship is in safe waters. So the navigator is going to measure the angle between the two lighthouses, and as long as the angle between the two lighthouses from where they are on their ship is less than 30 degrees, between 0 and 30 degrees, they are in safe waters. As long as the angle between the two lighthouses is less than 30 degrees, the boat or ship is safe. Okay. Example 8. UT is tangent to the circle. We want to find a whole bunch of measures. So we're told this is 30, this is 100, and this is 110. So we want to find the measure of arc WT. So if this is 30 degrees, and it's intercepting arc WT and arc TS, it's outside the circle, then we subtract 100 minus the measure of arc WT, divide that by 2, and we're going to get 30 degrees. So 100 minus the measure of arc WT divided by 2 equals 30 degrees. 100 minus the measure of arc WT equals 60 degrees. Multiply by 2. Subtract 60, add measure of arc WT, measure of arc, I'm just going to write it over here, measure of arc WT is 40 degrees, 100 minus 60. Measure of angle TVS. So TVS is this angle here. That's inside of the circle. So we add these two arcs together, divide by 2. 110 plus 100 is 210, divided by 2. 210 divided by 2 is 105 degrees. Measure of arc of angle RVS. This angle here. Well, it's 180 minus 105. 75 degrees. Okay, measure of arc RS out here. Again, inside the circle. So we add these two arcs together, divide by 2, and we're going to get this angle, which we already know that measure. So measure of arc RS plus the measure of arc WT is 40 degrees divided by 2 has to equal the measure of the angle that we just found, 75 degrees. There's just one way to find this. Measure of arc RS plus 40 equals 150. Subtract 40 from both sides and we get the measure of arc RS is 110 degrees. That's just one way to find it. We know 3 out of the 4 arcs that add up this circle. 110, 210, 250, plus what gives us to 360, another 110 degrees. That's just another way to find part D. Okay. Example 9. Segment AB and CB are tangents, here and here, to the circle. Express the given measure in terms of x's, y's, z's, and w's. So the measure of angle ABD, measure of angle ABD is right here. Okay, this is outside the circle, so we subtract the 2 intercepted arcs. So this is, what letter is that one? Is that the X? No, that's the X. There's the Y. That's the Z. A little hard to see it in my print. Hold on, I'm going to look it up. So I did just look it up. This is the Z, and this is the X. Just a little easier to see it now. All right, so if this is Z and this is W, it's Z minus W divided by 2 is equal to this angle. Equals Z minus W divided by 2. Angle ABC. Angle ABC is this angle here. This angle is equal to this arc subtracted from 180, which we have in our book. So 180 minus W plus Y. And I put those in parentheses on purpose because in the end when I distribute it's 180 minus W minus Y is the answer to part B. Without that theorem that we have in our book, that's a much harder problem. Okay, part C, the measure of arc AD if ABD, the angle, is 20 degrees. So if this angle here is 20 degrees, we're not going to use the Z. Okay, we want to find the measure of arc AD in terms of W's and Z. So Z, it's this formula here. We know this is 20. This is what we're looking for. And this, okay, so we have 20 degrees equals measure of arc AD minus W over 2. Multiply both sides by 2. 40 degrees equals the measure of arc AD minus W. Add W to both sides. This is equal to W plus 40. Find the measure of arc EC, which is the Y, if we know that angle DBC, so now we don't know this is 20, new problem. DBC we know is 50. Okay, so 50 degrees is equal to x minus y divided by 2. X minus, I'm not going to use y, we're going to say measure of arc EC divided by 2. Multiply both sides by 2, 100 equals x minus the measure of arc EC. Add the measure of arc EC, subtract 100. So the measure of arc EC is equal to x minus 100. Example 10. Find the x to y ratio. Okay. So, well, what are they equal to? For the one where they're intersecting inside, we add x plus y, divide by 2, and that equals this. So we have x plus y divided by 2 is equal to 2n. Okay. For the angle that is outside of the circle, we subtract these two and divide by 2. So we have x minus y divided by 2 is equal to n. Okay? Well, I know what n is. It's x minus y divided by 2. I'm going to plug that in here. So I have x plus y divided by 2 equals 2 times x minus y divided by 2. 2's cancel. X plus y divided by 2 equals x minus y. Multiply everything by 2. X plus y equals 2x minus 2y. I'm going to add 2y to both sides, subtract x from both sides. Slide up. So adding 2y, subtracting x, I get 3y equals x. We want the x to y ratio, so we're going to flip this around. X equals 3y. X to y ratio is a 1 to 3 ratio. 1 to 3 ratio. That's the end. Thank you very much. Bye.